this is very simple recall. Name the 3 particles inside an atom and give their charges. Okay, hopefully you can recall that the 3 particles are protons, neutrons and electrons. If we look at their charges, a proton has got a positive charge, so easy to remember, P and P together, so protons are positive. Neutrons are neutral, it's got neutrons, neut and neut for neutral, so in other words they haven't got a charge. And then electrons are what's left over, so if you've had protons which are positive and neutrons are neutral, therefore the only charge left is a negative for the electrons. So what word do we use to describe a charged particle then? We call them ions, so that's I-O-N-S, not with an R as in the metal ion, but these are ions. Then looking at this chemical here, it's asking whether this is an element or a compound, so we need to know what an element is, which is a chemical that's made up of one type of atom only, whereas a compound is a chemical that's made up of 2 or more different types of atom. So now that we've got those definitions, we can see here there's clearly 2 different types of atoms, looking at the 2 colours, so therefore it is a compound. Looking at this picture here, or symbol, H2, it's asking whether it's an atom, a molecule or an ion. So an ion we can discard straight away because, as we looked at earlier, a charged particle is an ion and this hasn't got charge on it. An atom would be a single H by itself, a single hydrogen, so therefore we can say that this is a molecule of hydrogen. Okay, it's a group of atoms joined together. Yes, they're both the same, but there's more than one atom there, so it's a molecule. Again, asking the same question, is this a molecule, an atom or an ion? Hopefully straight away this negative charge here indicates to you that it's an ion. Okay, so let's have a look here. We've been given an electronic configuration. So electronic configurations are how many electrons there are in each shell, starting from the first shell, so the one closest to the nucleus. Here we've been given that the electronic configuration is 2, 8 and then 1. So what group is this element in? Well, if it's got 1 electron in its outer shell, it must be a group 1 element. Next question asks what period it's in. So again, we can use this electronic configuration here. The fact that there's 1, 2, 3 shells, okay, so 2 electrons in the first shell, 8 in the next, 1 in the final shell, that's 3 shells in total, suggests that it's in period 3.